Hi, everyone. Welcome to our meetup, Kubernetes Security by Design, Build It Right the First Time. It's 5:05. We'll wait another 2 minutes before we start because one of our panelists, Thomas Fricke, had some emergency and he's just coming in within the next, so we should wait until he's there. So the timing will be like this. What we're going to do, we're going to go for 3 talks, all about 12 to 15 minutes. First, starting with Jur, who is the head of security at Cloudical, and go on to Thomas, who will then give his talk, and last but not least, Ram, who will talk about how to secure your Kubernetes. And after that, we'll have a 15 minutes Q&A session. If you have any questions, we will not be interactive until the Q&A session. If you want to ask questions to the Q&A section and put your question into this. We have now 67 people. We have a sign up in 50, so we'll wait another minute. Jurland, please make yourself available. I think in 1 minute I'll go and hand over to you. You're muted, so.
Sure. Thank you, Torsten.
So, handing over to Jurland. Let's do the first talk with him, and here we go.
So hello, everyone. Thank you for being here. My name is Julian Budrushi. As Torsten already said, I am head of security at Cloudical. So this is me. It's the same guy you saw in the picture. I just cut my hair recently. As you all know, that you cannot go to the barbershop. What I'm going to talk today is about security in Kubernetes and why you need the holistic approach. So by that, the agenda would be as follows. At this moment, I would like to stop the camera. The agenda would be as follows. I'll start with the motivation. We'll then provide a brief introduction to security, and we'll conclude with an holistic view on that. So let us begin. According to Gartner, through 2025, 99% of cloud security failures will be customers' fault. And this is a very concerning prediction, don't you think? So, and I'm sure you don't want your company or business get hit by lightning. When you go to the Kubernetes website, you will find the following definition. Kubernetes is an open source system for automating the deployment, scaling, and management of containerized applications. Nevertheless, in practice, Kubernetes has evolved and can be undoubtedly called as the cloud operating system. It is a well-known fact and very important to emphasize that operating systems are highly complex constructs. And is also a well-known fact that complexity is the first enemy of security. And the more lines of code we have, the higher is the number of potential errors in there. Nevertheless, error bugs or flows can be found even in protocols consisting of only 5 simple steps. And more importantly, sometimes it takes decades for these flows to be identified or be known to the general public, as shown here by the example of the Needham-Schroeder authentication protocol, which was vulnerable to replay attacks, and this was found out only 17 years after the protocol has been published. So please don't panic, it's not all lost. I would really recommend the talk of Rob Joycey, Chief of the Tailored Access Operation at NSA, about disruption nation-state hackers. And in a summary, the takeaway messages of these talks are: know your network, know your devices, and know your security. But what does security actually mean? When you talk about security, it's not uncommon to get similar answers as the following: no incidents ever happened to us. There is nothing to take from us. Our data is not confidential. Our network is secure, or our employees are trustworthy. To better understand security, we need to know what goals it actually aims to achieve. And here are the most common one. Starting with confidentiality, which is the practice of keeping secrets, maintaining privacy, or concealing valuables. Integrity, which is the fact that the data has not been modified. Authentication, which includes integrity, and it can be divided in two steps. First one is the process by which one entity, the verifier, is assured of the identity of a second entity, the claimant, that is participating in a protocol, or the ability to determine the origin of the data. Last but not least, availability, which is the property that legitimate participants are able to access a service within a timely manner whenever they may need to do so. And of course, there are furthermore. When we talk about security, we also come across the term of information security. But what does information security mean? Information security means that we want to protect information which can be stored on paper, in computers, and in people's heads. Whereas cybersecurity, it covers all the aspects of information security, and in addition, also communication technology. Finally, it is of crucial importance to understand that security is a process and not a product, meaning that security is a continuous, integral, multi-layered, and multi-dimensional process chain of information technology that comprehends technology, people, the environment, and their interactions. Now that we have a better understanding of what security means, let us complete this understanding by introducing a holistic view of it. When you go to the Kubernetes project website, under the security section, you will find the so-called 4 C's of cloud native security. The question here is, but what actually lies behind this high level? And this we are going to see in the next slide. A holistic approach of security starts already at the management level, namely the governance. And here we have to make sure that adequate resources have been assigned and are made available, that compliance requirements and policies have been defined and communicated to all the employees, and adequate security concepts have been developed and implemented accordingly. The next thing we have to think about it is the facilities. And at the facilities, we have to think about, for example, if there is an adequate disaster recovery plan. In other words, how good can we cope when a catastrophe happens? Is there maybe a resiliency strategy? In other words, that our services are always running no matter what. And also, is there any physical security measures in place such that not everyone, let's say, can access the data center? When going to the next level, namely the hardware, here we have to think about For example, if we are using an authentic and latest firmware, and also if we have hardened our hardware, meaning that functionalities that we do not need, that are not used in our context, have been disabled. In other words, to close and to narrow the surface, the attack surface. Are we using provided security modules, such as trusted platform modules that enable a secure booting in our environment? Going to the next level, at the operating system level, we have to think about, again, are we using an authentic and latest version of the operating system? Have we hardened our operating system, meaning that functionalities at the operating system level which are not needed have been disabled? Secure configuration. Did we configure our operating system securely? For instance, by partitioning. Security modules. Have we used security modules provided by the operating system, such as host firewalls? Access control. Is there an adequate access control in place which it implements principles such as least privilege, need to know, and separation of duty? Further, we have to think if there is a mandatory access control in place rather than the default discretionary access control. Another point is logging and monitoring. Are we logging and monitoring critical activities? And next is security tools. Have we installed security tools, let's say, for instance, an antivirus? At the container and runtime management, as already mentioned in my talk, you have similar questions as on the level of the operating system. The other speakers will touch more into details and will give you insights today in two specific areas, namely secure configuration and access control. At the network level, it is relevant to make sure, have we separated and segmented our network in different security levels where different security requirements and measurements are in place? For instance, when we have separated test, development, and production environments. This is very important, especially to mitigate the so-called persistent threats, or also known as lateral movements. Are we using secure protocols? In other words, is the communication in our network encrypted and authenticated? Further, are we using security tools such as firewalls of level 3, 4, or 5, and as well intrusion detection or prevention systems? Going the upper level to the application, it is important to assure that we are using an authentic and latest version of this application, that this application are properly written in secure programming languages. And we know what I mean with that is, for instance, programming languages that use type enforcement. And again, are this application have been written by following software patterns while they have been developed? Did the developer follow strictly software patterns, which enable us to avoid well-known bugs or well-known errors? Usually, to access the services in our environment, users use their own clients from all around the world. So these are the door actually to our environment. So, and at this point, we need to think if these clients are compliant to the respective requirements that need to be fulfilled for accessing our environment. And if these clients, for example, are equipped with security and privacy enhancing tools. At the next level, at the user level, who actually are the weakest link in the security chain, and therefore we have to make sure that users are constantly learning and participating in educative programs. in order to avoid, for instance, being victims of social engineering. And there, for example, are using strong authentication mechanisms, such as two-factor authentication mechanism. And finally, all this already mentioned before should be thought within a process and also integrated in a lifecycle management. And this is not new, everything we have touched so far, but as the Latin saying says, that repetition is the mother of all learning, we should think of all of this topic when we want to secure our environment. So it's your duty and responsibility. Therefore, depending on your computing model, you have to understand where your responsibility lies. And you have to understand your attack surface and implement adequate detection and mitigation measurements. And please don't do this at home. Addressing specific security requirements or issues is very important, but not sufficient. Rather, a holistic approach is necessary to achieve and maintain an adequate level of security. With that, I thank you for your attention, and I'll hand over to Thorsten.
Thank you so much, Gerland. I think this is really the start of security. Make sure that you know what's happening, what you're going to do. I'm going to hand over to Thomas in a second. Gerland, could you stop sharing,
Sure.
please? So, after some technical difficulties, we have Thomas in the line. Thomas, welcome. It's your time to share what can go wrong in Kubernetes. What's Kubernetes? What's Kubernetes all about? So please, Thomas, if you unmute yourself, that would help also.
It is. Can you hear me?
Yes, perfect.
Perfect. And my slides are visible also? Yes.
Yes.
Great. So, yeah. We have seen what possibly could go wrong in general, and now I give you the details, or a little bit of details, how you can introduce security into Kubernetes. And the best rule, as always, is try to enforce simplicity in Kubernetes, which means you are responsible, unfortunately, as Gerland already said, to educate yourself and to introduce security and to reduce the complexity of Kubernetes. You have seen my bio. It's not pretty interesting. This is a little bit about the history of Kubernetes and just what I want to say and to introduce it. It started with a little bit, a tiny game application, Pokemon. Now we are seeing Kubernetes migrating into critical infrastructure. So from a Pokemon to whatever energy or traffic control systems or healthcare, it only took 4 years. So this is really fast. And the bad news is security in Kubernetes was introduced, pod security policy here, introduced after all the other things already have aligned. So sometimes we see a misfit. And in the beginning, it was all about it, Star Trek naming and a lot of jokes about this. Now it's a serious business. And we see where Kubernetes is used. And this means we see it in military planes, we see it in ships, we see it in trains, banks, shopping system. And this is more or less my area, healthcare and energy control. And a little bit, this is Gaia. We see it in the German Gaia X project, the next generation of a federated cloud. So Kubernetes is all there, and therefore security in Kubernetes is one of the more important topics in the near future. And you are responsible means, yeah, first thing you would probably do is you would go to the internet and then look for examples. And unfortunately, we see a lot of outdated and insecure examples. So here are examples how to implement an insecure version of an outdated version of Tiller. So Tiller version 2 uses a service account. RAM will tell you how this can be exploited to get access to the entire cluster. So don't do this, please. It's a bad example. We see it from one cloud vendor and the others are not really better. So the two of the bigger cloud vendors have wrong installation instructions. Another example is Istio. So the Istio sidecar is great. Istio is a service mesh with a zero trust philosophy. So zero trust means you don't have to trust your network, and therefore everybody likes in a distributed cluster environment Istio. Unfortunately, security is not established completely until you do Istio with a CNI plugin, which is already there, but not used very widely. And another bad example here is how you install Elasticsearch. So with definitely privileged init containers, this means you can start any application from the init container. And this requires that the user who is running Elasticsearch needs a privilege to start this kind of privileged container. They are doing changes on the host system. We will see how far this goes. So here are the links to the examples. Please don't do this. It's outdated, it's wrong, it's not really recommendable anymore, but nevertheless, it's in the documentation on the internet, and you see a lot of things more where you can get installation procedures which are completely insecure. Next step is, wrong advice is cheap. You already have an Istio plugin, an Istio CNI plugin. It's already there since 1.2. We have 1.6 now. It could be used, but nobody is actually rolling out the latest version. They have outdated versions. It looks like, we would never had forgiven Microsoft these outdated versions, but they are in place all over the world in every cloud, more or less. You find examples for this outdated version. So please check it. Why is the Istio plugin, or you should go for the CNI plugin? Because there is an exploit. You can use this exploit to circumvent the security of Istio. Okay, you have to be a user on the system, but this means you simply, by good old IP tables rules, you switch off the Istio sidecar and can go wherever you want in that thing. And the real reason here is you allow netadmin privileges by default, and this has to be controlled by other means. So it's your responsibility not to roll out netadmin capabilities. And for this, you have to know all the places in Kubernetes where you could have an insecure setting, which is a lot, and therefore we will probably have to use a tool and that cannot do it manually. We will see how this works later. So this is the state of the cloud at the moment. It's already fixed partially, but you are responsible to roll out the fixed version. I sometimes receive customer requests, oh, we have a service account and we want to go live, and we do not get rid of the first consultant who introduced that service account. Why is this a problem? Oh, we are a bank. Okay, what is your deadline? In 2 days? 2 days? This is definitely not possible. So please have a concept before you roll out service accounts and kinds like this. And the concept is well known. It means please run least privileges wherever possible. And it's to know that you are running least privileges, you have to have a certain knowledge on that. And least privileges in Kubernetes means we have to know how to separate concerns required by an application. I have one example here, which is borrowed by Elasticsearch. In older versions, they have fixed it nowadays. You see, you have init containers normally, then you have main containers in a sidecar, with a sidecar. You have an init phase where only the init containers are running. It's more or less only a little bit overlapping with the running phase. And then you have the ready phase where you valid to be connected to the internet. So in the ready phase, it's really getting hot, so you can get a connection to the internet. Here is a typical example how it was in the beginning for Elasticsearch. They are using best practices, so they are not using this anymore. You see, you have a sysctl call from a very privileged container calling something on the host. So it's changing the host setting, which is more or less undefined because the last container which runs the sysctl wins normally. And if you have two containers with different settings, you don't get a defined state. And you have a more or less quite innocent second container initializing the database system. And then you have a running main application. And what we see in customer installations normally is you place an application here, running it as root or on a changeable file system or on a container which has a sudo command installed. And this means if it's running, somebody can exploit it. So Java is not the best example here. Let's imagine a WordPress. So we from time to time see problems in WordPress, then you get access to the main container. And if the main container has a sloppy setting, which means privileges, it also could get access to the host. So you have a full path here from the internet through the main container to the host and can change the host settings, which is definitely insecure. So we have to protect this. The first thing is, check it. But how can you check if a container has access to the host container? The best thing is separate the concerns. So try to eliminate this link here in principle. The first step is we see the init call only has to be done once, and then you place it in a different container in a daemon set, and then you run the sysctl and it terminates, and the daemon set must not terminate, so you are using a pause container. And in this susceptible phase, it's only for a few seconds. And then the pause container takes over, no connection to the internet. So this cannot be attacked. And the best thing is you address it in a different namespace. So you are running it in a namespace. We are sure that there is no security vulnerable container running. And then your main application becomes completely harmless. So you have a connection to the internet, you have a proxy, you have might have even network policies or later on Istio. So you have everything running as non-root, non-privileged containers. The file system also can be exposed non-privileged. And this means the attack vector going directly to the host is not possible anymore. You see here, you can use port 8080 or another non-privileged ports. You don't have to expose your container to the outside world, giving root access to anybody. So this can be enforced. And then the checks are quite simple. Here you check simply, we have no privileged container running in our application namespace. And on the other side, you simply check, we have no container running with connection to the internet. So you can separate it. And this is to be considered as best practice for your application setup. Separation of concerns is important. Now you have a privileged and a non-privileged namespace, and this can be checked by easy kubectl scripting approaches or by better things. So another example which goes further into that direction is use a pod security policy. It's confusing. It came late into Kubernetes. It's very poor supported, breaks more or less all Helm charts. You have on GitHub that stable Helm charts don't work with pod security policy. So argument again is simplify. Why is it confusing? So there is no well ordering symbols. You cannot say this policy is better than the other. It depends on what you are aiming for. Network, host access, root processor, things like this can be completely different. So try not to have multiple pod security policies, just choose one per namespace, because if everything goes wrong, it's alphabetically ordered, and the pod security policy, which is first in the alphabet, is normally applied. So if you have permissive, restricted, strict, very strict, and unbelievable strict, it's always permissive. And then you have no advantage of the other pod security policies. Okay, so again here, simplify, try to have one namespace, one service account here, set the role-based access control right, use only one role, one binding, and every application should be started by the service account. And most of the superpowers of the service accounts are not needed in user space. And creating messy setups was never easier, so don't fall into this trap. Try to make it simpler, but it's your task to make it simple. Thanks, and I'm here, and I give back to Thorsten, and Thorsten will collect all the questions, and we will do a Q&A session later.
Yes, thank you very much, Thomas. Now, you did great in probably made up lots of questions. How is my Kubernetes set up? Did I do it right? Did I do it wrong? What can I do? What can't I do wrong? We'll answer that in the Q&A session. But first of all, we have Ram with us, who will present us something, how the hackers view of Kubernetes is and what things are up there. So up to you, Ram, please. And everybody else, please write down your questions so we can answer them in the Q&A session. Thanks a lot. Ram, please share your screen. Ram from Octarine, here we go.
Yeah, so hi everybody. As Thomas mentioned, my name is Ram from Octarine, and yeah, there you go. And today we're going to talk a little bit on like the hacker view of Kubernetes, how hackers, what is an easy way for a hacker to hack into Kubernetes and to gain access over the whole clusters. One question I noticed came up, and I know we're supposed to wait with a question to the end, was about Helm Tiller version 3. And we're going to touch on it. So we're going to get it covered. Cool. So let's jump right into it. So Kubernetes is a game changer. Kubernetes is in the middle of two major changes that happen, by the way, regardless of Kubernetes, but Kubernetes is a big enabler of those. So in one hand, we have the tech stack, like we're changing or we're moving from monolithic application into microservices. Again, it happened way before Kubernetes was around. However, Kubernetes is, it made it easier than always to create new microservices and to put it in production. So what we're left with is like many workloads done or pushed by the team. On the other side, we have a change that in many cases is overlooked, which is the organizational changes. We moved from central groups like ops, DevSec, into a movement, we call it a DevOps, but it actually means that we distribute a lot of the ownership that used to be owned by those groups into the development team. So now with Kubernetes, we're left with many workloads, and they all on the ownership around managing them, securing them, is now distributed across many teams. This is, in many cases, a nightmare for security. Going back to this slide, I think Jordan touched on it a little bit. So when you go to the CNCF and look at Kubernetes, you see this diagram, which is putting Kubernetes as just one layer between the container and the cloud layer. But when you look deeper into Kubernetes, you realize that Kubernetes is more than just a layer in the stack. It's actually a very, very powerful one. With the list of capabilities we listed on the left, you can look at Kubernetes as a layer that can actually affect other layers in the stack, where you can manipulate your cloud resources or change some of the container configuration only with Kubernetes. So as I said, it's very, very powerful. And with great power comes great responsibility. And this is where the hackers kind of a great opportunity for the hacker. The reason why it's a great opportunity is for two reasons. So first, not a lot of people today out there understand how powerful Kubernetes is. So it's, again, they leave it unsecure, and it's an opportunity for the hackers. But second, because Kubernetes can touch or change other layers in the stack, hackers prefer to focus all their efforts into this environment, into this layer in the stack, and basically gain access or gain the key to the kingdom. Okay, so let's jump into it. Let's try to hack it. One thing that I didn't mention, I know I'm going real quick through the slides. It's all going to be available eventually. We have links for everything that I'm going to show today, so it's available. So right after that, look for that slides and try it yourself. So let's talk about the hacking demo, what we have here. We're gonna show Kubernetes privilege escalation, like how can you gain access to one container and from that container basically take over the whole cluster, and by doing that, have access to the cloud infrastructure. We're going to use Helm, or we're going to show how we hack Helm version 2. Helm version 3 does not need Tiller anymore. So this does not, this exploit that I'm going to demonstrate today does not exist on Helm version 3. In many cloud environments and in many resources out there, you see that the instructions are still around Helm version 2. Helm version 2 is still widely adopted. So keep that in mind. It's still very adequate hack or vulnerability. There are two scenarios. I'm going to show only one because of we are short in time. But again, use the slides later. Try it yourself. The second scenario is in there. Okay, so let's talk a little bit about Helm Tiller and Helm in general. So if you never heard about Helm, Helm is the packaging system for Kubernetes. With Helm, you can easily deploy a package around an individual application that you need to install that basically consolidate all the objects or assets in Kubernetes into one package that you can easily install with one command. It has an in-cluster Helm server. Again, it's not applicable on Helm version 3. Sorry. It listens to Helm client, and I think the most important thing is it needs a cluster admin role, and we'll see why it's an issue in a minute. Okay, let's go through the demo scenario 1 and what's in here. So basically, we have a cluster, which I'll show in a minute. We have my app, which is just an app, and Tiller on kube system. So those are two different namespaces, my app and kube system. We have a load balancer, ingress controller. I think it's very straightforward. Excuse me, very straightforward cluster. And let's see what a hacker can do. So this is a pre-recorded demo that I'm going to talk over. So here's the cluster. As I said, very simple cluster. No much in here. I'm going to exec into the container called dashboard, which is to simulate like what a hacker that was able to exploit a container can see. So as you can see, a hacker has access now to the container. Can do PS, basically has a root access on the container. I'm doing like with my fingers, quote unquote. And let's see, there you go. So what can we do? The first thing we'll do is, there you go, is get kubectl. So kubectl just downloaded. So Kubernetes or pods are coming very secure by default if you haven't changed anything. So the default service account that connected or attached to the container is very restrictive. So I use the command auth-can-I just to see what is available for the container by default. And as you can see, nothing. There's not much I can do by default on the container. I'll try to do get pods, for example, nothing. I'll try to do get secrets, nothing. So there's not much I can do. Okay, so what next? So the next thing I'll do is try to look for a tiller. Tiller, most users, they install Helm by default with the same set of configuration, the same listening port without authentication on kube system namespace. The name of the tiller is tiller-deploy, as you can see. So just by doing curl -v, as you can see here in this command, I tried to kind of look for a tiller and I found it. So what next for me? So the next thing will be to download Helm client. Again, very straightforward. It's out there. It's on the internet. Do Helm ls. Oh, this is Helm. Doing Helm version, and there you go. I have access to the tiller. So now I can interact with the tiller. Keep in mind, tiller has cluster admin. So now, at this point, by the way, it's a game over. I have access to the cluster, but I'll show you in a second how it can be exploited and how easy it is to actually exploit it. So I have my own Helm chart that I set up. As you can see, it's a very, very simple Helm chart that has nothing, just a simple container that is a web shell. So I'll just install it. I'll do Helm install. There you go. And install for that chart, Helm ls. It's running. All I need to do right now is to basically interact with a web shell that I just put in the cluster. The web shell has an admin role in Kubernetes. So the first thing I would do is just get tokens, but actually I can make it even more interesting. And in this case, what you see here is I did kubectl get secrets -a, capital A, so it's on all the namespaces. So now I see that the secrets on the cluster. The next thing I'll do here is I'll output it to a YAML, meaning I'll get an output of all the secrets that I have in all the clusters. As you can see, some certificates, tokens. I basically have the key to the kingdom now. Like, I have everything. Cool. So what do I need to do in order to prevent this from happening? And I listed some steps that you can do. And we talk a lot about all those in a few minutes. But again, look at how complicated it is to kind of prevent this from happening. Scenario 2 is very similar to scenario 1 with one different. We add a network policy between the two namespaces, and we show how a hacker that basically have access or somehow got the laptop of one of your developers can gain access to tiller. The demo scenario 2 is available on the Git repo. Again, check it out right after that presentation. There is a video there that kind of show exactly what I just showed. Okay, so I showed you how Kubernetes can be hacked or exploited. How do I secure Kubernetes? So there are few tools baked into Kubernetes. Thomas touched on some of them. I'll kind of glance through them quickly. The dynamic admission control is a tool provided by Kubernetes and can help prevent changes in Kubernetes unless they're approved. But security policy, which is, by the way, super complicated, and I think, again, Thomas touched on it, baked into existing Kubernetes can be utilized in order to prevent a lot of the things I just showed. RBAC, like this is a role-based access control existing Kubernetes, again, very complicated, but should be utilized in order to make sure that only the people that have supposed to have access to some of the resources will have access. And lastly, network policy to help segment the cluster, or at least prevent access between namespaces or between workloads, even though, as you will see running through the demo later, or the scenarios, that it's not always simple or helpful. So as I said, it's not so simple. There are a lot of tools. Most of them are not as simple as you would expect a security to be. And those are some of the challenges. So I touched on the many tools, and there are many tools out there. There are not just the Kubernetes built-in mechanism, but there are also some open source tools or some tools provided by different contributors or companies. And most of them either easy to set up or not so easy to set up, but very distributed, which in many cases is a challenge. Going back to the change, the internal change or the cultural change, the ownership of security is questionable. Like who's really supposed to own security? We see in many companies that the people that's supposed to do it, or company expect them to do it, don't necessarily care because they have other responsibilities. And the people that care don't always know how to do it because Kubernetes is fairly new and super complicated. And the people that might be able to do it don't care and don't know. So security in many cases is a little orphaned, and we see it, we hear it oftenly from customers. The current approaches with enforcement is way too late in the process. We do it right before the workloads are running in the cluster. Today's enforcement mechanism put an emphasis on CI/CD, like shifting left, and there is no out-of-the-box support for this. And we'll show how we do it in Octarine in a few minutes. Multi-cluster is a challenge in general, not just in security. Kubernetes and multi-cluster is still an open question. And we see that the filtering capabilities on the network policy is very, very limited. So I touched on many tools. This is just an example of some of the tools you can find out there that can help you with some of the security challenges you're facing today with Kubernetes. All of them are open source. Some of them are even, I think I put a competitor here. But again, slides will be available. Check them out. So when it comes to Kubernetes, you often feel like you need a team of experts to secure Kubernetes. You need the Avengers. And this is where we come into place, like Octarine, DevSecOps simplified. What is a security for enterprise adapted through Kubernetes in these days, the way we see it? So we believe that since you have so many workloads today, the first thing you need to do is prioritize, like rank your workloads by risk, understand the risk first. And once you understand the risk, like be able to put the spotlight on the areas that should be, you should focus on as a team. And forced to set a policy, like how do we make sure that we deny insecure workload as early as we can on the process? And this is where the shift left comes into place. Now, when I say deny insecure workload, it has to, I think it comes from two major needs. One of them is, of course, security and best practices, but the other one is compliance, where we see that most of the compliance framework trying to figure out how to handle security Kubernetes today, because Kubernetes changed a lot of some of the basic concepts that they rely on. I think a good example is PCI, when the framework is very, very specific. And now comes Kubernetes that kind of change a lot of the underlying concepts that the framework is built on. Delegate, empower. Again, going back to the cultural change where a lot of the responsibilities are now delegated to the team. So we want to delegate and we want to empower the teams, but in order to do that, we need to educate them, and we need to have the knowledge base spread or descriptive enough, so even a layman, quote unquote, again, known as lame, can understand what's the implication of the things he's doing. And last is protect your workload at runtime. So we want to make sure that once the workloads are running, you have the ability to protect them. Coming Octarine. Octarine is a company I work for, of course, founded like 3 years ago with a mission to address the challenges for Kubernetes security. There are two major components to Octarine, which is guardrails and runtime, where guardrails help cover the enforcement of security throughout the application build life cycle, starting from build all the way to deploy. It helps with security, best practices, compliance, and everything in between. And then second piece is the Octarine runtime. When we have security, we embed security into your Kubernetes application with network policy, egress policy, IDS, anomaly detection. So all the good things you need on a runtime environment that has many workload and super dynamic like Kubernetes. A few examples, or I'll touch on some of the features we have in Kubernetes. So the first thing is like application risk. This, by the way, available as an open source, and I'll touch on it in the end. I'll leave you with the link to it, where we look at all the workloads that you have in your cluster. We developed a mechanism called KCCSS, which is a way to rank risk on Kubernetes configuration. So what you get when running it is a full list of all the workloads with the risk associated with the workload based on the config set of that individual workload, with a breakdown of each one of the vulnerabilities, the way we see them, and what is the implication of this vulnerability. As I said, this is all available as an open source where you can run it on your own cluster with no data leaving the cluster, just to give you a way to see what are the risks you currently have with your cluster. Automated admission control policy, meaning we have a policy engine basically, and giving you the ability to control what's getting into the cluster. So we list out all the capabilities allowed in Kubernetes. Some examples like privileged, shared host PID, host IPC, shared host network, all those things. And for each one of them, we let you decide if you want to block, allow, or alert. Very useful for compliance, but also for security. We have integration with CI/CD. So again, going back to shift left, when we want to enforce security even before the Docker container being built, so you won't have any insecure containers out at the wild. We have an IDS running in Kubernetes, meaning we look at the traffic between workloads within the cluster and can alert when we see some attacks or potential attacks, help prevent lateral movement. I think we are among the very few companies out there or solutions out there that are actually looking at the east-west traffic. And lastly, you get notified with everything that's going on to your preferred channel, either Slack, PagerDuty, whatever. Like, it's very, I think, common and well-known methods. So of course, there is way more than what I just showed. I needed to kind of pick a few examples to give everybody a taste of what's in Kubernetes. Touched on kubescan on the open source. So here's how to get to it. It's called kubescan. Look for it in GitHub. Run it today. Evaluate your risk. Know what's going on, and reach out to us if you want to learn more. With that said, I'll turn it back to you, Thorsten.
Thank you so much, Ram. Thank you so much, Thomas. Thank you so much, Jerlin. Well, lots of information in a very short period of time. As you can see, we let this have the start. What we will do, we'll host a Kubernetes virtual workshop for 2 hours on May 7th at 10 a.m. Berlin time. Obviously, if you guys have any questions, all of us are in the business. We're ready to answer questions. We're ready to give you solutions. Obviously, right now, what we want to do is really put an effort putting Kubernetes security out. I think one of the questions I would ask all of them is, now, Kubernetes, I thought this was safe. This is why we started using it. And what's happening now? Maybe all three of you could just run through that, and then we'll go more to the more specific ones. And I would like to have an answer from everyone. Maybe Gerland, you start, and then Thomas, and then Ram. What would be your answer? Very short, please. You're muted.
Yeah, thank you for mentioning that. That is actually the point I wanted to make with my presentation, that Kubernetes in itself, it's a very complex construct. So taking this for granted that is secure, it's the wrong mindset. Getting to know it and understanding what are the configuration and the features, or where the platform can be secured, and understanding where the platform is being used and for what kind of business processes, this is the mindset that you should approach using the product.
Thomas, what would you say?
Yeah, I would say Kubernetes is a perfect opportunity to make things very secure if you understand it well enough. And the complexity is absolutely overwhelming. It has the complexity of a data center, and nobody in a single person understands the data center completely. So be prepared to make your experience. And yeah, what we also have seen is the bad old examples in the net are everywhere, and they don't go away. And so please try to understand what's going on, use your old system engineering know-how, and yeah, make it really secure. It can be very secure, but not if you simply copy and paste examples from the internet.
And Ram, what would you say?
I would say embrace the fact that all tools probably not going to work with Kubernetes. All security, mainly all security tools. Kubernetes changed a lot of the concepts, and I think eventually bring a lot of cultural. We touched a lot on the cultural changes, because I think it's a key to understand like how the future environment is going to look like. So if you are going to try to force your old tools work with Kubernetes, Kubernetes won't work and you won't have security. So try to think of new approaches to security in Kubernetes, and I think that would be the only way to fix it eventually.
Thanks. So what I would like to do now is go through the questions which you guys asked. Farid asked, what can you tell about Kubernetes LDAP integration in terms of security, flexibility, recommended or not?
Yeah, sometimes you must do it because it's your company policy, and the user and group part of the roles are attached to normally your LDAP integration. So it's mostly ADFS or something like this. So you can use Active Directory for this. You also have other OpenID tools, so it's all OAuth 2, and you can delegate security to an OpenID provider or something similar, but you have to be able to change settings on the master server, because it's a parameter on the master server. It's possible, it's well hidden sometimes, but definitely you need to do it in a corporate environment, and it's a little bit of a bigger task sometimes. Did I answer the question?
Farid will maybe answer that later on. So another question from Mark. What is your stance on real-time container monitoring and prevention tools like Twistlog and New Vector in regards to visibility and alertability? Who wants to answer that? Ram?
I can take that.
It's competition, but or
So
not?
maybe I don't think it's a competition. And to be honest, I used Twistlock a lot in the past. So Twistlock covers a different layer in the stack. Not just Twistlock, Aqua, and all the container scanning. They are focusing mainly on containers and looking at the world from the container's point of view. I know they have more features around runtime and they're trying to get into Kubernetes today. And I'm not sure where this is going to go. But as I said previously, I think that Kubernetes itself is a beast in a sense, and it changes a lot of it's a game changer in many senses. And you need to have the Kubernetes view of the world in order to solve this Kubernetes security.
Thanks.
The security for Kubernetes, sorry.
Question for Gerland. There are any basic security steps should anyone work with Kubernetes applied? Because in startups, there's no DevSecOps engineer and should do all the work.
Sure, there are, and here I would recommend to look at the standards of CIS, a benchmark where you can find how you can do basic security configuration on Kubernetes depending on the different level, even by component and also by specific topic like access control, logging. So this is the first place I would look to in order to make sure that I follow the best practices.
Thanks. Chris asked the question, how can we delegate the responsibility across teams and enforce rules? How do we gain experience, training necessary to gain Kubernetes security knowledge?
Yeah, you have to build the knowledge, and I would start with a basic training. So you invest 2 times 3 days. And then you have a basic knowledge about this, and then you can avoid the most dangerous pitfalls. But it's an ongoing process. And actually, what you should start with is you should start writing your own requirements for security. So sometimes if I come to a customer who simply addresses me, I want Kubernetes security, then I ask, okay, what is your threat modeling? What is your level of security you are aiming for? Is it just a game, or is it whatever, let's say, a critical infrastructure? You have to clarify it before, otherwise it will be very expensive. If we go beyond the level you need, it can definitely be very expensive. We can link Kubernetes secrets to hardware security modules, but if you are not in a regulated environment, you probably don't need it. It's up to you to find out before what you really need. We can help you definitely, but this is a challenge, and then we can go through the most challenging questions you have and establish a base level of security.
Thanks, Thomas. I think this is what we all do in real life: sell the security, make workshops, give training, give best practice, and set up different solutions like Octarine. Next question would be, a lot of your suggested best practices are enabled by default in OpenShift version 4. What's your impression of OpenShift OKD?
It's a preview up to now. It should be out for a long time, but it's not really stable. And if you want to go for Atomic, then it's not really ready. We are waiting to a full-blown release in all of the clouds at the moment. And I would like to have a better and more complete answer soon, but at the moment it's a preview version.
Next question, what about having Kubernetes master public kube API servers? Wait a second, the question just got away, which is default on AWS AKS. When would you suggest to only use private access via VPN or Bastion hosts? Gerland, maybe you can answer that one.
Yes, sure. Yeah, I would suggest to use private access via VPN or Bastion hosts always when possible. The master server API has, let's say, has no functionality of being accessible by the internet. So you open the door to everyone by being able to access the Cube API server. So in order to keep the surface of the attack as narrow as possible, I would suggest to use this VPN or Bastion host or so-called jump hosts. But I would also again mention here and recommend that when you use Bastion host, you also have to think about the clients that are accessing this Bastion host, because this is the same. So you are just, let's say, shifting the problem, and you are not solving the problem. So by accessing that through a Bastion host, you should make sure that also this client accessing Bastion host fulfills some requirements. Otherwise, there is no gain into having this hop in between.
Thanks. A question from Björn. What is, from your point of view, best approach nowadays to secure publicly exposed applications where you cannot limit source of incoming connections via IP restrictions? I think about OAuth 2 or two-factor auth in front of your application. What can you recommend on this specific layer?
I think it's a good question for Thomas.
Yeah, I
I'm
think
not trying to throw you under the bus here.
You can place security sidecar containers in front of your application if you're normally Kubernetes from the network side of you have different possibilities to restrict the access to the container. So native normally is an ingress application, so it's more or less an Nginx reverse proxy, which can control a lot of things. You also could have sidecar containers which check for certain conditions, for example, for an internal LDAP server, a lot of more things. The best thing normally is to use client certificates for this and check this client certificates somewhere on that level. I don't know. I haven't done it with an ingress, but it should also be possible. And client certificates are always a good starting point for controlling client access.
Thanks. Question to Ram. Hosts not isolated so they can download whatever they want from the internet. I don't think this is a secure environment. Why not have the Helm charts stored locally in the network?
Thorsten, you've been breaking out. Any chance you can repeat that, please?
Oh, you can look into questions. You can see them, I think, too. If you go to Q&A, it's the second question.
Oh, yeah, so I went through this. To be honest, I'm not quite sure what Farid means here. If there is any way, Farid, you can elaborate here?
I don't know if Farid is still here with us. Wait a second. Farid, if you want to talk, I can give you, you can talk. There, you unmute yourself. You can ask the question or what you mean.
Yes, hello everybody. So my question is to Ram. He was showing us the demo, about the possibility of hacking the Kubernetes. And in this demo, I saw how we are downloading with the curl some packages from internet. The question is why we have this possibility of hosts to access the internet for downloading something, and why we are not using the, for example, if we need Helm to work, why we are not using the possibility of storing Helm charts locally in our network. not going to the internet, but in case if it is required, we can just use the Helm repo from our internal network. So why hosts should be exposed to internet, which gives us the possibility to download something and then run the code in the Kubernetes. And also, I will. This is the second. This is the first question, and second, it's not question. It's a comment, because I saw in your presentation that it's written. It's written that only L4 filtering possible, but this is the comment that I believe Cilium CNI plugin also supports L7 layer 7 filtering as well. So this is just a comment from my side. Thank you very much.
So thank you for good question. So regarding the Cilium, you're right, but it is not Kubernetes native. I was touching on what native in Kubernetes, which is network policy. This is a plugin or an add-on you can add for the company Cilium. NeoVector can do that as well. We can do it. So there are many other companies, not just Cilium, that can provide you a better policy mechanism like layer 7. But yeah, it's a good point. Going back to your question about why hosts are accessible to the internet. Well, by default in many clouds, this is how it is. You can restrict access from the host to what we call egress, like access to the internet. But keep in mind that in many cases, you will need to pull some information from the internet, like from your Docker repository or whatever repository. In case you have it locally and it's all isolated, then yeah, just lock or prevent access to the internet. So keep that in mind. What we see in most of in today's cloud environments, that a lot of the services that used to be owned by the enterprise, like monitoring, logging, is now provided as a SaaS. So you do need to access those services. With Octarine, we have a way to whitelist what's going on outside, like egress from your cluster, to basically help prevent what I just showed. So it's a great point. Thank you for bringing it up, because I have a good answer for it. I think the second part was about Helm, like why can't you host your Helm charts internally? And the answer here is yes, of course you can. There are some open source like Harbor, which is Helm chart repositories that you can put inside your cluster, and then just pull your Helms from it and make sure that the traffic never leaves the cluster. As long as you do not you're not using any community charts that need to be pulled from the internet. Well, you can pull them from the internet, put them in your own repository. So I think the short answer is yes, you can definitely do it, but it will require some resources, some time on your side to spend on setting up the right tools and making it happen. By default, the community is starting to kind of build around. Everything is accessible, everything is on the cloud, everything is out there in the internet, and what you want to control is the activity, not necessarily prevent it from happening from the beginning. Hope it makes sense.
Thank you.
So I think there is one more question, which I think everybody could give his point, and I think we should come to an end on that one, which is, what is your recommendation for establishing a security regime from the beginning? I think we've heard some answers, but now from all three of my panelists, answer, which in 3 sentences should be, and short sentences, not German long sentences, should be answered. So I'm starting with Jerlin in the beginning.
Yes, so thank you for that. I maybe just want to take the time and go back a little bit to the question Abdel Rahman had with respect to which steps they should go, where I suggested the CIS benchmark. I know that this is a long list of things of securing that, but the question is how you can check that you did it right. And there I want to recommend that there are, for example, the KubeScan, which is an open source tool you can use. After you do the configuration, you can use that to check in order that your configuration has been implemented as actually wanted. So this is a good step to verify, because yeah, as we say in German, Vertrauen is good, but Kontrolle is better. So you have to control, and this would give you the possibility to check that you did the things right. Coming to the last question, the recommendation for establishing a security regime from the beginning. My opinion on that is, first you need to understand, starting from your business model, understand where your responsibility lies, and second, you need to understand your attack surface, and this is depending on your business goal and business processes that are going to run on the platform. And third is to enable your let's say your employees and your users, the ones that are going to use the system, by training them or by providing them the necessary tools.
Thomas?
Yeah, where to start? So actually, in the example Ram has given, if one of 4 recommendations would have been used, then the attack would not be possible. So use Helm 3, use unchangeable file systems, don't expose root, don't allow anyone to install software in a container. So this would all help. In general, we would see make a clear architecture set up from the very beginning, which everybody understands, which is easy to test. And then you introduce the simplicity in your application, and then you can check it quite easily. If you have a messed up application with a lot of tools with different privileges, you will not be happy, and probably 95 or if not 99% of the applications don't need privileges, and the other ones should be isolated. So this can be done, and this is quite a discipline you have to bring into the process of running containers, but it will work. And then use tools like KubeScan or the other Octarine tools, or whatever, or even simple scripts to check if your assumptions are right. You can test it, you can test network policies, but you have to do it. You have to plan the time, and if you are in a critical environment, then you need to spend the time to do the security right.
Ram.
Yeah, so what we see is security is a journey, especially when it comes to Kubernetes. You start knowing things, and you soon realize that you don't know anything, or you know nothing, and you slowly learn as you go. So I would recommend 3 things, like visualize, make sure that you know what the risks are. And so be able to visualize it for yourself and monitor it. Delegate, so make sure you have the ability to eventually delegate some of those responsibilities to the team, meaning educate. Like, so you need some tools to educate the teams, or tools that can help support educate the team. And lastly, enforce. Make sure that you can enforce some capabilities and understand the impact of this enforcements. If you have those 3, you can easily iterate, learn, educate yourself, learn more about your requirements, business needs, and easily have the right ways to enforce security.
All right. Thank you, everybody, for joining this. It's 1 hour 20 already, which we did, so a little bit longer than we thought. Nevertheless, thank you so much. Feel free to reach out to everyone to us. We will provide the links of the slides and of the recording of the webinar for everyone who's registered. If not, send me an email. You see my email on top of me. So everything else, if you have any questions, if you really want help, if you need help, reach out to me, reach out to Jerlin, Thomas, and yeah. So thank you very much for joining. Thank you so much for the panelists, Ram, Thomas, and Jerlin. I think you did a great job, and I hope opened some new perspectives on Kubernetes security. See the Kubernetes virtual workshop, which we'll do on May 7th. I posted the link in the chat, so you can register already. So if you want to take part, have any specific topics you wanted to answer. Thanks a lot. So one round of last words, and we'll start the other way around. Last word from Ram, then Thomas, and then Jerlin, and then we'll stop.
Thank you very much, everybody. Thank you for the opportunity. Stay safe on these crazy days and be secure.
Yeah, be secure, and Kubernetes has all the opportunities, but don't underestimate the complexity.
Yeah, so thank you very much for your attention and for being there with us. And yeah, hope to see you in joining our next webinar and learn more about it on hands-on.
So stay safe, stay healthy in this curious times, and hope to see you all soon in one room or more rooms when this COVID crisis is over. Thanks a lot. Bye-bye.
Bye-bye.